Hello guys, today we're going to look at processes, how to create processes and how they work. First of all, let's write a main function. Inside that main function, there is a printf function called. Let's execute this and see what happened first. When you execute the program, you see that the printf function displays the dash. Now, a process is a program in execution. A program is a set, we can see a program as a set of instructions. When a process starts, the process executes the set of instructions. And while it's executing the instructions, the state of the process gets updated. For example, a process has its own address spaces where the variables are, all those things. So when the instructions tells, for example, to change some of the states or the variables values are going to be changed if we explain it in a simple way. So when you run a program, a process is started and the process execute the instruction from within this program. This is what we do when you run the program in the terminal. You see that only one process start and this process execute this program. A process can create child processes. Those child processes are copies of the original process, and the copies also continue to execute the same program, meaning the same set of instructions. I'm going to display we're going to show on the screen an image and see how or, creating processes works. On this image, you see that we have this green box. Inside this green box, we have these things, I'm going to call them instructions. So this represent a program. And when you start a program, when you start executing a program, a process is created. So I'm going to draw an image, a figure, a shape that represent a process. So when a process starts, it starts executing the instruction in the program. And let's say this is where the process uh, is currently executing. Great. So what happens when you create a child process? A child process, as we said, a child process is a copy of the parent process. So a child process, when you create a child process from within the parent process, this is what is going to happen. The child process also is created. Let's add the shape. So a child process is created. I'm going to change the I'm going to change the color. So here we have a child process created. And now what happens, the child process also start executing the program where the parent, where it has been, where we created it, let's say here. So the child process continue executing the same program, and the parent also continue executing the same program. So all these start executing the same program till the end. What happened? A program is just a set of instructions, and these instructions are executed by processes, and these processes they have separate address spaces. So when a child process is created, it will be a copy of the parent process. And if we have variables in the parent process, let's say like that, variables, and you have certain things retaining the state of the process, these also are going to be copied in the child process. So the child process is going to have the same copies, the same values, except some other informations that kept the child process different from the parent process. The child process has its own process ID, and the parent process also has its own process ID. The only thing is they're executing the same program. And we also have to understand that when a child process is created, it starts executing the instruction from where it's been created. So if in the program you call the fork system call function, from this point, the child process get created and it will start executing the program starting from the same place and goes down as the parent. The parent also continue executing the same program. The parent program doesn't stop after the system call for creating the child. So a, a better way to represent this is that each of these processes will have a copy of the program, separate copies, so they're completely independent in regard of the program they're executing. Let's go back in our editor and see how this works. In a C program, when you want to create a child process, you call the fork function. When you call the fork function, a child process is created and the process start executing the program. The parent process continue executing the program. The child process also continue execute the same program. Let's see what happened. gcc main.c, the output file name will be called program. Yes, we need to include a library called the unit std library so we can use the fork function. gcc main.c, the output file name will be called program. So you see that we have two dash, the first dash and the second dash. One of these dash was displayed from one of the processes, either the parent process or the child process. Now, how to predict the output of this particular program? I'm going to split the screen in two parts. So you have these instructions. I'm going to call this, let's say you have, I'm going to call this instruction 1, and this is instruction 2, and this one is instruction 3. So here at instruction 1, let's say the program, you started the program started executing. We are here in the parent process. And when you are on the line instruction 1, this will create the parent process, um, execute the fork statement. So a system call will be made to create a child process. Now the child process is created, then after that, the parent process execute the printf function, and after that, it return. Now, since the child process has started, the child process started from this this line. So it's going to start executing the next instruction. As if you remember in our previous drawing, you see that when a child process starts, it starts executing the program where the parent has created it. So the same things goes for the program here in the code. So the child process also execute the instruction, the printf instruction, and after that it return. So this is why we seeing two dash appearing in the terminal, because the parent process created the child run the printf function and return. The parent process continue its execution, call the printf function and return. So this is exactly how it works. What happened when you have other fork statement? Let's see, for example, if you say, I want to create two child processes. What will happen if you type in something like fork and fork again? So according to the program, we call the fork statement 3 times. As if you remember, the child process and the parent process execute the program. So the processes that started from here are going to continue executing the program. And in the program, there is two other fork statement left. And the processes that start from the instruction 2 will continue executing this one. So in the text here, this is how it works. We have the parent process. The parent process start creating a child process by calling the fork statement, and the parent process continue. It's called the second fork statement that creates a child process, and the third fork statement, and after that call the printf function, and after that return. Now we have 3 processes created from the child process. Now, what we're trying to do is to guess how many dash is going to appear on the terminal. Now, the first child has been created from the first fork instruction. So the next instruction the first child is going to see is the second fork instruction. So it's going to create another child process and also execute the other fork statement. Then after that, the function is called, and after that, it's returned. Now this is the second child created by the printf by the parent process. The second child was created from here. So the next instruction in the program it's going to execute is this fork statement. So the second child will create another child, then call the printf function, then after that return. Next, the last child that the printf function called was from the third instruction. So what happened is it is just going to execute the next instruction and the return. So this is a breakdown. Now we're going to execute each of these child processes till we're done. So the first process is which has been created from instruction 1 in the parent created a child process from here, and this next child process is going to hit on the next instruction, which is the fork statement. So we're going to have a child process created from this process, and next the printf function, and after that return. The second child, here in for the first child is just going to hit on what? It's just going to hit on the printf function. So we'll see something like printf and return. So this is what we have to understand is that each child process starts executing the next instruction just after the next instruction in the program from where it has been started. And if we continue now, this one, we see that this one has one child, and this child is just going to hit on the next instruction. So here we have it's being created from here. So from here, so the next instruction is going to hit on is the printf function, and after that, it's going to return. Now we can continue with the last one. Is also going to hit on the printf function and return. So how many processes we have? We have the parent process, one parent process, 2, 3, 4, 5, 6, 7, 8. So we have 8 processes. So we're going to have uh, the printf function is going to be executed how many times, because each of these processes have a copy of the program, and we're going to have 1, 2, 3, 4, 5, 6, 7, 8 printf function call. So 8 dash should be displayed. Let's execute this program again and see what happened. Oh, I forgot to save it. Let's execute it again. Here it is, we have the dash, and if you count the dash, we have 1, 2, 3, 4, 5, 6, 7, 8 dash. This is the logic behind it. A process can create another process. So whenever you call the fork statement, you have a, a process is created, and it start creating other processes. It start executing the next instruction. So if the next instruction tells to create a process, it will create a process. Now there is one other thing we need to learn and understand. This is how to know that we are in the child process from our C program code. I'm going to type in something like if fork is equal to 0, we print child. And after that, we say else, we print I am the parent. We print parent. So the fork statement return the process ID. When you are in the parent process, the fork statement return the process ID of the parent. It return a non-zero value. But when the child process start from the same instruction, the operating system will return a 0. Then we know that from within the child process, we are in the child, but let's execute this code first. GCC main.c, the output file name will be called program, and that's it. When you run this program, you see that parent is displayed and child also is displayed. How this is possible? The fork, a function returning a value that is at the same time equal to 0 and not equal to 0, this is not logical. Something fishy must be happening. So this is because when you call the fork function, the parent for the parent process, the copy of the program for the parent process, the return value from the fork is different than 0, so we see parent. And when the child process starts, it will have the same copy of the program and start executing from the fork, but this time the operating system will return 0, which means that we are, so for the child process, the operating system is going to return 0 instead of a value different than 0. So we know programmatically that we are in the child process. This is why we see in the terminal child. Now we understand that the fork function, depending on which process we're in, return different values, or the operating system may return different values from these processes. Next, what is the next step? What if you want to create, oh, I forgot to add the return statement. There's no warning because when you run the GCC command without the flags, there are certain things you can't see. So here, what if you want to create, let's say, 5 child processes? Or just let's say 3 child processes, and we're going to display the dash. You can predict the output of this program. Now we have one problem, is that each of these child processes, depending on where they have been created, is going to execute the next instruction. If the next instruction is a fork statement, then it's going to create another child process. But we only want to create one single, exactly 3 child processes, and we want to display the printf only 3 times. We want to execute a printf function only 3 times. So there is a way to do that. We can say if fork equal to 0, then we call the printf function. We display the dash and we exit, or just return. Or you can call exit, it's the same, exit. So when you are in the child process prints the exit function, but is not going to execute the other instruction down here. But the parent process is going to continue to execute because the fork statement will return a non-null value. If fork is equal to 0, let's say I'm just going to copy this block 3 times. So this will be child 1, child 2, and this is child 3. And this printf function will be from the parent process, parent here. Now let's compile this code. Oops, the exit instruction has we need to include the stdlib library. And now the first child process created from the parent is going to create it. Then for the child process, this function is going to return 0 from the operating system. So it's going to execute this instruction, but instead of continue executing, it will hit the exit statement, then it will stop. The same goes for the other child processes. This is how we create multiple processes from a parent process without worrying whether these processes are going to continue executing the rest of the instruction from the program. Now let's compile and run. And here you see, and here you can see child 1, child 2, parent here, then child 3. Oh, we have a problem here. Something I'm going to explain. Why does the parent displayed first, then child 3? It means that the parent process has terminated before the child 3. So, since the parent process terminated before the child process, this is possible because the processes are independent and they're each doing their own works. It's like you have, when you create, it's like a, you're working or you're executing a set of instruction from a paper. Then you call someone else, you tell him, okay, I want you to execute the same instructions starting from where I called you. But the other person is independent from you. The same way the parent process is independent from the child process. It can terminate before or after the child process, depending on how the operating system is executing the things. But we cannot predict which one will terminate before um, first. So you can make the parent process wait for its child. So for the parent process, you can say, okay, I want you to wait for the child process before you terminate. With that, we have the wait function. The wait function calls the parent process is a system call function that tells, okay, we want to pause the parent process till all the child or till a child died. For example, we're going to make it wait 3 times because we have 1 fork statement, 2 fork statement, and 3 fork statement. So we say wait. And yes, the wait function is from a library called syswait. And this function receives a, a status variable which holds the exit status of the child process. But we're going to execute this program, then explain. Now you see that the parent terminates after the child. There is something else I want to add. What if the child takes time to execute? Let's say, in order to make things more simpler, So if we are in the child process and after that the child take sleep, the child take let's say 10 seconds before exiting, that means the parent process won't exit till the the child process is done with its works. But for now, let's execute this program without the parent process waiting for the child. And you see that the parent terminated before the child. Now we're going to make the parent wait the child before terminating. So then the parent won't terminate. The parent will not terminate till the child is terminated. So here the child is sleeping, the child is doing something for 10 seconds, and the parent is waiting. So when the 10 seconds are um, passed, finished, the child process exit. Then after that, the operating system start the parent process. Then we see that the parent process terminated displayed on the terminal. So this is how we use the wait function. Maybe sometimes you might need the parent process to re you might need the parent pro sometimes the parent process might need um, to wait for the child process. Maybe the child process is doing some kind of works and the parent process is waiting that the child process finish and use the result of that work. One example could be you have multiple files and you want to work on all these, process all these multiple files at the same time. So you create a lot of child processes. Each child process is working on one file at a time. And this is the logic behind it.